Here we are with graphing trigonometry number 2. So here we're just going to focus on the sine function. Okay, just graphing the sine function, whether it's in degrees or radians. And typically we deal more with radians, but we're just doing some degrees to kind of help us get the idea down still. So, a few things to remind us about. Okay, this is all connected to the unit circle. The thing is, we've just taken the x-axis, and that represents our degrees or radians. And the y-axis represents the sine function. Remember, the sine function is related to the y value of these points, right? All these points up here. So this is what we're graphing, okay? So kind of a way to look at it like this, we're graphing that distance from the x-axis up. That's the y value. See how it matches up here, pi fourths. That would be the angle pi fourths, the radian pi fourths, radian pi halves. Okay? And really, when we're graphing trig, there's 5 major points that you want to use. Okay? And it goes back to this unit circle. So if we start here, this is 0, right? I go up to the halfway, or I guess a quarter of the way. That's like 90 degrees, or pi over 2. We go half a circle, that's 180, or pi. Down 3/4, that's 3 pi over 4, or 3 pi over 2 I mean, or 270 degrees. And then back to 360, or 2 pi. Okay, so 1, 2, 3, 4, 5. Those are the 5 main points you want to use when you're graphing. So this is the sine function. Okay, once again, the x stands for our angle in radians or degrees. The y value is our sine function for that. Okay, so this shows more points. This is going by 45s instead of that. So here's the 5 major points. For sine, the parent graph always starts out at 0, 0. Unless, of course, we've got a vertical shift happening. Okay? But, I mean, the parent graph is the parent graph, so it starts there. Then notice that at pi and at 2 pi, because here, that's when it's on the x-axis, they're at 0. They stay on that midline. Okay? So they're always going to be on that midline. And the 90 and 270, or pi halves and 3 pi, the pi halves goes up the amplitude, which for the parent graph is 1, and down 1 for the parent graph, but the other ones could adjust that. But if you can graph these 3 points, okay, you can make any sort of changes that need to happen. Because there's the 3 changes. There's the change in amplitude, which will affect these two, make it go either up higher and down lower, or even skinnier. I mean, flatter, I guess would be a better word. Okay, there's the amplitude. We also have the vertical shift, or the midline. Okay, that's going to affect all 5 points as it moves up or down. These ones will always stay on that exact midline. But it affects every single one. The other one is the period. Okay, the standard period is 2 pi. So it starts at 0, goes to 2 pi. But if we change that period, it could shorten it and have the same shape, just squished together. Think kind of like a spring being pressed down. Or it can be elongated, that spring pulling it out. Okay. So here's the standard equation for sine. We're not worried about cosine right now. Okay, the amplitude is always the number in front of the sine. Get the absolute value of it. It's the half the distance between the max and the min, the peaks and the troughs. Okay, that's our amplitude. That's where we see it on our equation. This is where we see it on our graph. Okay, we've got the period. A normal period is 2 pi. That number in front of theta or x, when divided into 2 pi, that's going to give us how far out or in it's going to get squished or stretched. Okay, That's the period. So you see it not in that b, but in the 2 pi over b. So you have to do a little figuring to find that one. We see it from the start to the end, okay, in the period. And then frequency, we don't really worry about that one. The midline, k. The midline, k, is just that horizontal line. It starts out here. That's where we see it. But depending on what we get added on in the equation, that's where we see it. It's plus or minus a number. It'll shift this up or down. And we'll see it in between the peaks and the troughs. Okay? So, let's get to graphing some of these. Let's go back to these ones. So, when we're looking at this, we need to think the three things. What's the amplitude? What's the period? And what's the midline shift, the vertical shift? Okay? So, it's A times the sine of B theta plus K. Excuse me. Do we have a number in front of the theta? No, so it's 1, so our period is 2 pi. Do we have a number being added here? No, so it's 0. So our midline we know is right here on the x-axis. Okay? Our period is going to be 2 pi. So I can already say that, let's see, here's the parent graph, right, to remind us. It looks smaller because our y-axis is smaller. Okay. So that's what it looks like. So ours, because it matches that parent graph here and here, is going to be the same for that part. Okay. So we're going to start at 0, 0. We're going to go across at 180. We're going to end at 360. Okay. Now what about the amplitude? Well, the amplitude here is 4. So that means instead of going up 1, I'm going up 4, and instead of going down 1, I'm going down 4. So my graph is going to reach clear up there, come back to 180, come clear down here, and then back up to 360. And if I really wanted to, I could just keep going with it like this, but I don't need to. As long as you've got one period in there, you're good. And there we go. There's our graph. So, once again, it's always a good idea to draw that parent graph just to remind you what it would look like. Okay, because that can help you decide where to go. So here my amplitude is 1/2. I don't have a number here, so my period is 2 pi. I don't have a plus number, so my midline is still at 0. So my midline is still there at the x-axis. So for my graph, it's gonna, those 3 points on the x-axis are gonna stay the same because of the period and the midline. But my amplitude is now only going half the distance. So it's gonna be shallower, just like that. Alright? So it really comes down to having those three things, those 5 points from the parent graph, and then understanding how they get affected by each one of these. Alright. So, 3 and 4, you look at these, you should realize, hey, these ones are going to be pretty simple again. Got an amplitude of 2. My period is going to be 2 pi, because there's no number, and my midline is going to be 0. Same with this one. My amplitude is 3, period is 2 pi, my k is 0. So, now this one's in radians, but it's the same idea. Okay, my parent graph starts at 0, then goes up to 1 at pi halves, then back down to 0 at pi, at 3 pi halves, down to -1 at 2 pi. Goes like that. So same over here. Okay, those 5 points. With those 5 points, we can get a really good idea of what it's going to look like. Now, because we're not moving our midline, it's going to stay here, right? We're not doing anything to our period, so these 3 points on the midline stay exactly where they're at. Now the amplitude is simply going to affect how high up and how far down. So this one's 2, so it's just bumping up 2, bumping down 2. There's my new graph. This one's 3, bumping up 3, bumping down 3. There's my graph. Okay, same idea regardless of degrees or radians. Okay, now let's take a look. Now we're adding some more stuff to it, okay? So, once again, 0, pi, 2 pi, 3 pi halves, pi halves. There's my parent graph, right? And it's a good idea to actually draw the parent graph on there first, just so you get used to knowing what it is. So, my amplitude is not 1, it's 1/2. Okay? There's still no number in front of here, so my period is 2 pi. But now we've got a k here. My k is 1. So instead of my midline being right here, it's going to shift up 1. Okay, so that's my new midline. But because my period's the same, on that midline, this point shifts up 1, this point shifts up 1, and this point shifts up 1. Okay, it's just shifting that up, just up 1. But I can't, it doesn't affect these other 2 points, my point at pi halves and my point at 3 pi halves, because the amplitude will affect those. So my amplitude is 1/2, so I just go from the midline up 1 and from the midline down 1/2. And there's my new one. Okay, number 6. This time we've got a k of -1. So that's going to shift. Oh, let's check our period first, right? Our period isn't affected, so still 2 pi. So it shifts down 1. So my 0, 0, my pi, and my 2 pi are just shifted down that -1. Then my amplitude. My amplitude is 2. So my pi halves from that midline, that new midline I have right here, it's going up 2. So it's actually in the same place, and it's going down 2. So it would look like this. That's my new graph. And it would just keep repeating that same way. Okay, that's how they work. Either way, they just keep repeating. Just over and over and over and over. Alright. So 7, I think we've already done 7, haven't we? Yeah, must have got repeated somehow. So same idea for number 7. Okay. My k is still 0. My a is 4. And my period is still 360. So it looks just like that. Okay? So period is still 2 pi. If I look at number 8, didn't we? We did one similar to this, didn't we? So kind of like that one, just with the -1 instead. So my midline shifts down to -1. My period is still 2 pi. So I start at 0. 180, I hit my midline again. 360, I hit my midline again. Then my amplitude is 1/2. So I go up 1/2 and down 1/2 at 90 and 270. Wanted to kind of show you if you didn't, because those ones were kind of simple too. Alright, now we're going to get things a little crazy. So let's first put our 0, 0. Now notice my numbering's a little different here. Okay. But my parent graph on this one would look like this. So still a good idea to put your parent graph on. Okay, like that. Now, my amplitude is 4. My midline shift, my vertical shift is 2. So I know it's bumping up to 2. Okay. So it's shifting everything up to 2. But before I put those lines on, now I've got a number out here with pi. So that's going to affect where I can put these 3 points, right? So that's b. B equals 2, but that's not our period. To get our period, we go 2 pi over b, so 2 pi over 2. Then simplify. 2 over 2 is 1, so we get pi for our period. So instead of 2 pi, our period happens in half the time, because pi is half of 2 pi. So essentially all of these have to shift this way to have that happen. So I still start at the 0 on my y-axis on my midline. Okay, but now I'm ending at 180. Before, that was start, that was end. So I've just taken it back half. So what's half of 180? It would be 90. So my middle point is 90. Okay, because this is always in between the beginning and the end. Now, I got to go halfway between those 2 points, because 90 and 270 were halfway between the 3 right here. And then my amplitude is 4, so I pick right about there, about 45 degrees, and go up 1, 2, 3, 4. And go down, pick right about there in between, 1, 2, 3, 4. So kind of the way to think about it is, with those 5 points, you're always starting on the y-axis. Okay, whatever your period is, that's where you end, whatever that period ends up being. Guess I should hurry and draw this graph, huh? That's what it would look like. Okay, then halfway between is always going to be that middle one. That's halfway between the start, first and the last. And then your other 2 points are always going to be halfway between them. And the first one goes up, the second one goes down. Unless it's negative, then you flip-flop them. But I don't think we have any of those. Alright, so let's try number 10 now. Okay, so my amplitude is 2. Notice B is 2 as well, so we kind of know what that's going to be. B is 2, so I go 2 pi over 2, which becomes pi, so my period is pi. And my K, my midline, my vertical shift is -1. So I'm going down here to -1. But I'm starting out right here, right? And I'm ending at pi. So in between 0 and pi is pi halves, so that's where that one is. In between pi halves and 0 is pi fourths, and I'm going up 2 because that's my amplitude. Between pi halves and pi is 3 pi fourths, and I'm going down 2. And so that's what my new graph would look like. Okay, 11 and 12. So here is our parent graph. Sometimes that x-axis gets changed based on what you're going to have to do. So sometimes they'll adjust that and make it bigger or longer. Okay, but that would be the 2 parent graphs, right? I know all these parent graphs will look different, but it's because of the length of my x-axis. So on 11, first off, my K, my midline shift is up 2. So we shifted our midline up here. Okay. Our amplitude is 3. And our period is, well, pi over 2, or theta over 2 is like 1/2 theta. So I'd go 2 pi over 1/2, which is really 2 pi divided by 1/2, which we can't, so we get the reciprocal in times. 2 over 1, which is just 2, so 2 times 2 is 4 pi. So this actually stretched it out. So instead of 2 pi, it's 4 pi. So I still start here on the y-axis, but now I'm going out to 4 pi. Well, what's half of 4 pi? It's 2 pi, so my middle one is 2 pi. Then what's half of 2 pi is pi, so that's right here is where it's going to be. But my amplitude is 3, so I'm going up 3. And then halfway between 4 pi and 2 pi is 3 pi, and I'm going down 3, so right there. So this is bigger and stretched out, and that's my new graph. Same idea for number 12. My midline, my K is 1, so there's our new midline. My amplitude is 4, so from that midline, I'm going to be going up 4 and down 4. And that's like 1/3, so 2 pi divided by 1/3 would really be 3 times 2 pi, so it'd be 6 pi, right? Because it'd be 2 pi times 3 over 1 instead of divided by 1/3, so that's why. So 6 pi is my end, and the y-axis is my beginning. Now, we cut that in half, and that's 3 pi, so that's the third point on our midline. Now, what's half of 3 pi would be 1.5, so in between 1 and pi, or pi and 2 pi. And 3 pi to 6 pi would be, between 4 pi and 5 pi. So I'm going to go up 4, right here about, and then down 4, right about there. And there we go. Alright, so that's graphing the sine.